I am Jacopo. I'm a third year PhD student at the University of Sant'Anna School for Advanced Studies, and I'm studying anthocyanin synthesis in tomato, which is my research area. We are selective breeding these new type of lines of tomato, which are able to accumulate high quantities of anthocyanins in the fruit, which will then be able to further enhance their nutraceutical potential and serve as a novel food and possible new type of cures for sicknesses and further enhance the diet of all the people in the world. Specifically, my talk here at the conference was about anthocyanin synthesis in tomato, but on the influence of temperature and climate change on the anthocyanin synthesis in tomato. In fact, as the climate change advances, there is a rise in earth temperatures and in extreme weather events such as heat waves. And the rise in temperature has a deep impact on the anthocyanin synthesis in tomato. And in fact, all the fruits, when grown at 30 degrees, will basically drop the pigment content and the anthocyanin and the amount of anthocyanins in the fruit. This has a dramatic impact on the nutraceutical value of tomato. And my research here was about finding new way of allowing tomatoes to synthesize anthocyanins even at high temperatures. And we're studying specifically the molecular mechanism behind this phenotype. In fact, we found a couple of proteins, which are named COP1 and HY5, which are involved in this phenotype. They are the key regulator of temperature-related anthocyanin synthesis. And we are developing a new line which will be resistant to this climate change deep impact.